Okay, so this is the Mathematics GCSE June 2023 Practice Paper 2, published by mathsgenie. You can download it from the mathsgenie website, or you can collect a copy from school, and we'll have those ready for you this week. Okay, so we're going to start off with question number one. And question number one is asking us to, first of all, write 0.83 as a fraction. Now, 0.83 is questions about place value. Obviously, zero is in the ones column. We've also got in the tenths column, we've got the 8, and in the hundredths column, we've got the 3. And what this is talking about, of course, is it is 83 100ths. So 83 out of 100. Question 2. Write down the value of the 7 in the number 5,791. Okay, this is about place value, but this time, instead of looking at place values after the decimal point, it's before the decimal point. So we've got 5,000. We have got 791. So that's in the tens and that's in the ones column. So in there we have the 7, which is 700. The value of the 7 is 700. You can write that either as 700, or you could write that as 700. Like that. So either written as a number or in words. Next question. What is the time 2 hours 25 minutes after 9:15 a.m.? So this question, it really is done best by counting on. We're going to count on 2 hours. So 9:15 plus 2 hours is 11:15 a.m. Then we can add on another 5 minutes, which will take us, so add on 5 minutes, which will take us to 11:20 a.m. And then add on another 20 minutes, we get to 11:40 a.m. So fairly straightforward there. Nothing wrong with actually showing us that little bit of extra working. Can give you a little bit of a helping hand, especially at the beginning of the paper where you're trying to be careful and slow to make sure you get those easy marks. So 11:40 a.m. Next question is about the language of mathematics. And in this one, we've got write down a multiple. Make sure you understand what the word multiple means. Multiple, of course, means lots of. So if we're talking about lots of 6, we are talking about the 6 times table. So you're going to probably imagine your 6 times table. If you're desperate, you can work out, just count on in 6s. So you go 6, 12, 18, 24, and so on. But of course, we know that 6 sevens are 42. So a multiple of 6 is 42. So we could have 42, or we could also have 48. And either of those two answers is acceptable there. So I'm just going to write in there the answer 42. Question 5, change 270 meters into kilometers. The word kilo means 1,000. And of course, there are 1,000 meters in a kilometer. So it's we're talking about doing a division here. So we're going to go, so it's 270 divided by 1,000. And interestingly with this, lots of different answers that you could have here. You could write it as 270 over 1,000. Of course, that is the equivalent to, as a fraction, 27 over 100. You could indeed write it as 0.27, which is the most common correct answer. So 0.27 kilometers there. Okay, so question 6. We've got the diagram shows a rectangle, which is obviously just below here. And we can see here that it's measuring 21 meters by 15 meters. On the centimeter grid below, draw an accurate scale drawing of this rectangle. Use a scale of 1 centimeter to represent 3 meters. So that means that 2 centimeters will represent 6 meters, 3 centimeters will represent 9 centimeters, and so on. And if we carry on like that, we should be able to see that we're going to do a division here of by 3. And that's going to give us, as a scale, we get 7. And I'm just making some notes up here to help you see what's going on down here. I'm going to go divide by 3 here, which is equal to 5 centimeters. Now we're going to get a mark for doing that because we've used a correct conversion. So even if you're not quite sure what to do with it, that division there by 3 is going to help us do this. So we're going to look to create a rectangle now that measures 7 centimeters by 5 centimeters. We're going to keep it in the same orientation. And we're just going to pop in some shape here. We're just going to draw in a straight line. I don't have a ruler on the screen, but we're going to use a straight line tool here. So that's just going to go across here. So 1, 2, 3, 4, 5, 6, 7 centimeters just going across there. So 7 centimeters in there, like that. Okay, so there's my first line. Just going to change the thickness of that so we can actually hopefully see a little bit more about what's going on there. And we should be able to get that just in there, and the outline there. We'll go to just make that a little bit thicker to be able to see it, and hopefully that should be able to see that. So there's my line there that I've drawn in, and we're going to do, that's my 7 centimeter line, and we'll create another one of those, and we'll just create a copy of that, and we're going to go 5 centimeters down at the bottom here. So 1, 2, 3, 4, 5 down to there, and we're going to have another one of those. So drag that up here, so we've got a nice rectangle here, up to there, and then across to here, and then one more line just like that. And remember, draw these with a ruler. You should have a ruler in your exam pack, and it's just a matter of going across here and making sure that that's done. So there we are. We have a nice 7 centimeters by 5 centimeters. Just count those just to check. So 1, 2, 3, 4, 5, 6, 7. Yeah, 7 centimeters across there, and then 1, 2, 3, 4, 5 down there. Nice and simple. Okay, so that was 2 marks for that. 1 mark for getting the correct conversion, and 1 mark for an accurate drawing. Question 7. Wazim is going to have a meal. She can choose 1 starter and 1 main course from the menu. Write down all the possible combinations that Wazim can choose. Now, on this question, lots of people think that you probably need to write down all of the full words, but actually you only need to write down abbreviations. So we're going to use olives, which we're going to call, we'll just call the letter O. So we'll just put O in there to say that we're going to do letter O. Dough balls, we're going to call D. Bruschetta, which we're going to call B. Lasagna, which we'll call L, pizza, which we'll call P, and salad, which we'll call S. Okay, so what we're going to do, just going to be clear about what we can do. We can have a starter and a main. Notice that there are 3 starters and 3 mains, so we are expecting to get 9 in total. Now, when you do this, it's usually a good idea to be very methodical with this. So I'm just going to start off by going, so I'm going to go O, and then L. That's my first one. Then O, and then P, and then O, and then S. And notice I've kept the O's fixed as the first one. Then we're going to go D, and we've got L for lasagna, D, and P, so balls and pizza, and then finally D and S, dough balls and salad. And finally down at the bottom we've got bruschetta, so we've got B, and then L, B, and then P, and then B, and then S. And fairly straightforward there. Nice, easy 2 marks. Fran is watching a film at cinema. Film started at 17:40. The film is 108 minutes long. When the film ends, Fran takes 15 minutes to get to the bus stop. The bus leaves the bus stop at 19:45. Does Fran get to the bus stop in time to get this bus? We must show all the key. Okay, so the first thing we probably need to do is think about this 108 minutes long. 108 minutes, well, that's just slightly less than 2 hours. Remember that 2 hours is 2 lots of 60 minutes, which is 120 minutes. So that's 12 minutes shy of that. So we've actually got, this is 1 hour and 48 minutes. So let's have a look and see what's going on here. So we've got 17:40. 1 hour after that is 18:40. And then we've got 48 minutes beyond that. So 48 minutes, well, we can split that into 20 minutes and 28 minutes. The reason I've done that is now we know that 1842 to 1900 or 7 o'clock is, that's going to be using the 20 minutes. So we're going to go up to 1900, uses the 20 minutes. And then we want to put on another 28, 1928 there. Okay, so that's when the film ends. So film ends there. I'm just going to tell the examiner that I know that that's what I'm doing there. So film ends. And now it takes another 15 minutes to get to the bus stop. So we've got to do 15 minutes on from 1928. So I'm going to do 10 minutes on from there and then add on another 5. So add on 10 minutes, 1938. And then add on 5 minutes, 38 plus 5 is 43. So 1943, Fran will arrive at the bus stop. So gets to the bus stop then. Okay, so let's have a look. Is that before 1945? Yes, it is. Fran will get to the bus stop at 19:43, so it arrives in time. Fran will get bus stop at 19:43, so does arrive in time. Right, question 9. A baker has 3 bags of flour, A, B, and C. Bag A and bag B contain the same amount of flour. Bag C contains 980 grams of flour. In the 3 bags, there's a total of 2,600 grams of flour. Work out the amount of flour in bag A. 2 ways you could do this. You could say that we don't know what it is in bag A, so we'll call that maybe an amount X. Remember that X is just an amount, and so we've got X plus X there, and we've got 980 grams there. And we can then say, okay, well, the total is 2,600. So what we're looking at is a very basic equation. So X plus 980, that's my total amount, is equal to the total that they've given us there. So 2,600. You can write that as being 2x plus 980 equals 2,600. Now, this is a calculator paper, so you'd be advised to get your calculator out to make sure you get this right. So we're going to now subtract 980 from both sides of this equation. So the lines in here. Subtract 980 from there. Subtract 980 from there. And look, we get a 0 pair. So we've got positive 980, negative 980. We've got a 0 pair. So on the left-hand side, we're just left with 2x. And on the right-hand side, we are left with 2,600 minus 980, which is 1,620. And finally, divide both sides by 2. Divide by 2 there. Divide by 2 there. We get 1x is equal to 800 grams. Okay, so work out the amount of flour, 810 grams. And the grams is already there on the answer line for us. The other thing that I will see a lot of people do is they'll just do the subtraction. They'll immediately subtract. So you just do 2,600, subtract 980, and that equals 1,620 using a calculator there. And then they'll just do 1,620 divided by 2. That is equal to 110. So the same thing again, alternative way of doing it. The algebraic method will serve you better in the long term, but the pure numerical method and just logic will see you through that question. Question 10. Here are the first 5 terms of a sequence. We've got the sequence going 1, 4, 9, 16, 25. Many of you will recognize that as being square numbers. So we've got 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So the next 2 terms of the sequence will be 6 times 6, which is 36, and 7 times 7, which is equal to 49. The next 2 terms, 36 and 49. Now, some of you prefer to look at the difference table. So we've got 1, 4, 9, 16, 25, and you'll look at the differences between those, and you'll say that between 1 and 4 there's a difference of 3, then 5, then add on 7, then add on 9, and so you're going to add on 11, which gives you 36, and then add on 13, which gives you 49. Either way is perfectly acceptable, either a difference table or looking at the direct square numbers. Okay, so this is question number 11. And in this one, Ashley counted the number of beads of each colour in a bag. Here are the results. We've got red is 4, blue is 8, and green is 2. And in here, we've got Ashley drew the bar chart to show the number of beads of each colour. The bar chart is not fully correct. So that means we've got to look quite closely at what's going on here. Let's have a look and see what we've got. Usually, the corrections are to do with scales on the axes or the bars not being the correct height. So let's have a look. Is the first one, let's have a look. First one, red is 4. That's okay. Yeah. Blue is 8. Well, at first glance, that appears to be okay, but let's just check. So we're just going to go 1, 2, 3, 4, 5, 6. Oh, it's only 7. Oh, wait a minute. There's something wrong here. So let's have a look. So let's look at this axis here. So 1, 2, 3, 4, 6. Aha. There's an error on this axis here. So first error here is that the labeling on the axis is not correct. So the numbers on the axis on the y-axis are not correct. So we can just write that in. So numbers on the y-axis are not correct. On y-axis, correct. And the other thing that's fairly obviously missing is that there's no label on the y-axis. So we need to say what the y-axis shows, and it's the number of beads of each color. So the y-axis should actually say number beads of each color. So the y-axis is not labeled, and the numbers on the y-axis are not correct. So we just write that in. So the numbers on the y-axis on the y-axis are not correct. And the second thing that's wrong, there is no label on the y-axis. Question number 12. Julian thinks of a number. 2/3 of Julian's number is 42. Okay, so 2/3 is 42. So what we're going to do, little bar model in here. So 2/3 of my number is 42. So this is if this whole thing represents the number. We've got 1, 2, 3. Nice little bar model. We can see that 2/3 is equal to 42. So that means 1/3 must be 21. 21 in each one. 21 there. Okay, so Julian's number must be, that whole thing must be equal to 3 lots of 21, which is 63. And then we've got to work out 3/7 of Julian's number. So, okay, so this time we're going to work out 3/7 of Julian's number. So let's draw another bar model here with sevenths. This time 1, 2, 3, 4, 5, 6, 7. Not brilliantly drawn there. We might just want to just rub out a little bit of that. Okay, so there's my bar. We'll just draw that around that. So there we go. 7 pieces in my bar. This time the whole number we know is 63. And we know that whole thing there is 63. And of course, 63 into 7 equal pieces. That's 9. 1, 2, 3, 4, 5, 6, 7 nines, of course, are 63. And 3 of those, so 3/7 is 3 9s, which of course is 7. Nice simple way of doing that, which works well for. So the answer here is just question 13. The diagram shows a right-angled triangle and a trapezium. The area of the trapezium is 5 times the area of the triangle. Perpendicular height of the trapezium is h centimeters. Find the value of h. This is the first question in this paper that poses a significant challenge for most people. So what we're going to do, we're going to take the old adage of work out what you can. The question is about area, so we can probably quite easily work out the area of our triangle. So the area of a triangle, base times height divided by 2. So I'm just going to write this down there, base times height divided by 2. That's equal to my area. Let's just work that out and work out what we can. We'll have picked up a couple of marks for doing that. So I've got 12 multiplied by 7 divided by 2. And the area in this case, 12 times 7, of course, is 84 divided by 2, 42 centimeters squared. Okay, so the area of the trapezium is 5 times that. So what I'm going to do now is I'm going to say 5 multiplied by 42. Type that into your calculator, you'll get an answer of 210 centimeters squared. Now, at this point, we need to go to our formula sheet. And in the formula sheet, you've got something that says in here that if this length is A, something like this, and this length is B, and we know what H is. We know that the area of a trapezium, is equal to a half of A plus B multiplied by H. Let's work out what we've got. We know that we know that A and B are 18 and 12, so that gives me a half of 18 plus 12 times by H. And 18 plus 12, of course, is 30, so that's a half 30 multiplied by H. Half of 30 is 15, so we get 15 multiplied by H. That is equal to 210. Because those two things must be the same, because the area of the trapezium is 210 and the area of the trapezium is 15H. So now we can say that 15H must equal 210. So divide both sides by 15. Okay, and we get an answer of, let's have a look, 210 divided by 15. Fairly straightforward, I think. If we do that, 210 divided by 15 is equal to 14. So H must be equal to 14 centimeters as being my height of my trapezium. Let's have a look on the answer line, and it's 14. Notice at this point, there's no, and it just says the value of H. So the centimeters are already here, okay? But there will be somewhere in one of the papers a mark for putting the units. So I'm just going to in here put in the units and just put in centimeters there. Question 14. There are only 5 blue cards, 2 green cards, and 4 red cards in a pack. Louisa is going to take at random 1 card from the pack. Write down the probability that Louisa will take a red card. Okay, so probability of red is equal to, how many red cards we've got? We've got 4. Out of how many cards in the pack? We've got 2 green, 5 blue, so that's 7 so far, and plus 4, which is 11. So it's going to be 4 out of 11. 4 out of 11 there. So 4 out of 11. Bruno is going to throw a biased dice once. The probability the dice will land on a 6 is 0.34. What's the probability that the dice will not land on a 6? Well, we know that the probabilities must add up to 1. So it's just going to be 1 minus 0.34 is my working. And you can type that into a calculator and you end up with 0.66. Yeah, answer there, 0.6. Question 15. The table shows information about the number of goals scored by a football team in 200 matches. Okay, so we know that there are going to be 200 matches here. Okay, work out the total number of goals scored in those matches. Well, 0 goals were scored 65 times, so that's still 0 goals. 1 goal was scored 52 times, so that's 52 goals. 2 goals were scored 43 times, so that means that there must be 86 goals there. And similarly, 3 multiplied by 41 is 123, and 4 times by 9 is 36. Now, at this point, we really should reach our calculator because you don't want to risk throwing away some easy marks. Okay, so calculator here. Okay, and we're just going to do 52 plus 86. So 52 plus 86 plus 123 plus 36 equals 297. 297 goals, so 297. Okay, so 297. Nice easy couple of marks there. So 297. Find the median number of goals scored by the team. Okay, the median. Okay, well, that's going to be a little bit more difficult. We're looking for the 50th amount there. So we've got so 100th amount, sorry, there. So we're going to be looking at, we know that's 65 there. And we know that, so that's 65 zeros, and then we've got plus another 52, so 52 plus 65, that takes us up to 17. Halfway through then, well, halfway through the data, the piece of value, the piece of data that's in there, so 117. There's 117 in there, 117, okay, just in there. Okay. So 117. We're looking for the 100th piece of data and the 101th. Well, that's in this piece of data here, so it is 1. So it's going. Question 16. Pens and pencils are sold in a shop. 8 pencils cost £1.92. Okay, so I'm just going to work out what I can here. So immediately, before I even look at the rest of the question, I'm going to work out the cost of 1 pencil. The 1 pencil, just write that next to it, is going to be £1.92. At £1.92 divided by 8. £1.92 divided by 8. Just again, we can use a calculator on this. So £1.92 divided by 8 comes out as being 24 pence, 0.24. The ratio of the cost of a pen to the cost of a pencil. So we know that a pencil costs 24 pence. Ratio of pen to pencil, so pen, pencil is 4 to 3. And so if the cost of a pencil is equal to 24, and clearly we can see here that to get from there to there is multiplying by 8. And so if we do that on here, we go times 8 here. 8 4 is 32, so a pen costs 32 pence. So now we know that pen is 32p, so 32p multiplied by 5 is equal to £1.60, so 160 pence, or £1.60. There we are, nice simple to do that there. So £1.60. Question number 17. There are 11 grams of fibre in 100 grams of oats. There are 2.4 grams of fibre in 100 grams of banana. Rachel has 40 grams of oats and 60 grams of banana for breakfast. Okay. Work out the total amount of fibre in this breakfast. Okay, so let's have a look, see what we can do. So we've got 11 grams in 100 grams of oats. So let's have a look at doing maybe 10 grams. So divide by 10 and divide that by 10. So it's 1.1 gram in 10 grams of oats. Then multiply that by 4. So 4.4 grams in 40 grams oats. And then 2.4 grams in 100 grams of banana. So let's do the bananas over here. So that was the oats. Let's split it and let's have the bananas now. So 2.4 grams in 100 grams of banana. So that's going to be 0.24 grams in 10 grams of banana. And then multiply that by 6, get 60. So 0.24 multiplied by 6 gives me an answer of 1.44 grams in 60 grams of banana. So the total amount of fibre in the breakfast will be 4.4. The total is 4.4 in the oats plus 1.44 in the banana. And that gives me 5.84. The fibre in the breakfast, so 5.84. Okay, we're going to have a look now at question number 18. So 18, we've got reflect P in the line y equals x. Now, to get the line y equals x, we've got to remember that the line y equals x is where the x coordinate is equal to the y coordinate. So that's what it's telling us. Okay, y equals x or x equals y. So if the x coordinate is 1, the y coordinate is 1. Okay, and if it's 2 and so on, so if the x coordinate is 2, the y coordinate is 2 and so on. Now you can see that's not working brilliantly on here, but what we're going to do is we're just going to draw that line in, okay, and hopefully we should be able to get that in very nice and easily. So it should go through the point 1, 1, 2, 2, and obviously 3, 0, 0, negative 1, negative 1, and so on and so on and so on. So we're looking at this line just here. Okay, going up here. So there's the line y equals x. We're going to get a mark for drawing that in. So there's my line y equals x. Now all I've got to do is take each vertex and make sure that we are reflecting that properly. So you can see here, this vertex here, it's exactly 1 unit across and 1 unit down. So we're going to put this vertex into here. Okay, and so on. And this vertex here, we're going to go down in, well, let's take this vertex just here. And we can see here, we're going to go 1 and a half, and 1. So that vertex goes to there. And then the final vertex here, we're going to go again, nice straight line all the way through. So it's going to go 1, 2, 3, and we're going to go 3 the other side, 1, 2, 3, and so it's going to go to there. So what we're expecting to see here is a nice triangle in here. When we draw it in, we'll try and pop in some nice straightforward lines in here. So it's going to go from this just here, going across here, like that. And hopefully we'll be able to start to see this as we make this a little bit better in terms of how that looks. Okay, so just move that around a little bit. Okay, so there we go. There's my line, and if we just pick that and just hopefully make that just a little bit clearer as to what's going on there. So if we just do a little format on there, we'll just pop it and make it a bit thicker. And we can go. So nice and easy there. Okay, we'll just take that little copy of that and bring that around here. So pop that up to there. There. Do that. Okay, so there. And then finally, another little copy of that. Okay, one more of those. We're just going to do a triangle there. It should be the same size as the original triangle was. And there's my transformed shape. There's a quick guide. If you have a piece of tracing paper on the exam, what you should be able to do is to trace the original shape, fold it along the mirror line, and it should fold exactly onto the image that you have just made. Question 19. A is equal to 5b squared plus 6. Now, this one really should be the easiest one on the paper almost, because what we can do here is we can go A is equal to 5, and it's just a substitution. So we're going to go negative 2 squared plus 6. Now, amazingly, you get a mark for doing that because that is a correct substitution. Now, my advice to you when you do this is you type it into your calculator exactly as it's written here. So you don't even need to worry about a multiplication or anything like that. If you just type that straight into your calculator, it will give you an answer of 26. So 26. Trust your calculator, trust yourself. Okay, and you get a nice answer there of 26. Question 20. Franklin goes on holiday to Thailand. Franklin wants to change £750 into Thai baht. He wants to get as many 500 baht notes as possible. The exchange rate is £1 is equal to 42.87 baht. Work out the greatest number of 500 baht notes that Franklin can get for £750. Okay, let's have a look at this. Now, I quite like the idea of doing this in a little ratio box. So we know that the exchange rate in pounds, and we'll call it pounds to baht, okay, is £1 is equal to, and we can do it as a ratio, 42.87 baht. And we want to get, so how much is he going to change? He's going to change £750. Okay, so all we're doing is we're timesing by 750 to get from there to there, and times by 750 to get to there. Okay, and that will give me how much money we've got there in baht. So we've got 42.87 times by 750, which gives me an answer of 32,152.5 baht. Okay, so now all I've got to do is we want to know how many lots of 500 go into that. So we're going to do 32,152.5 divided by 500. 500 notes I'm going to get. So just divide that by 500, and it gives me an answer of 64.305. 64.305, which means, of course, I get 64 500 baht notes and a bit left over. So the answer is just 64. Okay, so 64 there. Nice and simple. 64 notes. Okay, question 21. Taylor wants to invest £15,000 for 3 years in a bank. Shield Bank offers compound interest of 3.6% for each year, and Champion Bank offers compound interest 6.2% for the first year and 2.3% for each extra year. Which bank will give Taylor the most interest at the end of 3 years? Well, we can have a look at this. So first one, let's look at Shield Bank. We'll keep this on the left-hand side. So we've got 15,000 multiplied by 1.036 to the power of 3, because it's 3 years. And we can work that out. So 15,000 times by 1.036 to the power of 3 gives me an answer of 16,679. 16,679 pounds and 2 pence when we round it to the nearest penny. Let's have a look at the Champion Bank. So Champion Bank is going to be 15,000 times by 1.062 for the first year times by 1.023 for the next 2 years. Okay, so type that into the calculator. 15,000 times by 1.062 times by 1.023 to the power of 2. And that gives me 16,671 pounds and 21 pence. Okay, let's have a look. Which one of those is the greater value? Well, they're both 16,600. This one's 79, this one's 71. So the difference one. So which one gives the most interest? This one gives the most. So which bank is it? That was Shield Bank gives the most. And there's all my working to support it. Okay, question 22. The table shows the probabilities that a biased dice will land on 2, 3, 4, and on 5. The probability that the dice lands on 6 is 3 times the probability that it will land on 1. Okay, so let's have a look at this. So if it lands on 1, x times, it will be 3 times, so 3x over here. Now we know that the probabilities must add up to 1. So we've got x plus 0.1 plus 0.17 plus 0.12 plus 0.09 plus 3x must equal 1. Okay, so that gives me 4x plus, and let's add those together. So we've got 0.1 plus 0.17 plus 0.12 plus 0.09. Okay, that gives me an answer of 0.48. And that equals 1. Quick little bit of reorganization of that. Subtract 0.48 there to make a 0 pair. So 4x must equal 0.52. And then divide both sides by 4. 0.52 divided by 4 is 0.13. So that means that the probability of a 1 is 0.13. And the probability of 3 lots of that is 0.39 there for the 6. Okay, work out an estimate for the number of times that the dice will land on 6. Well, that's now fairly easy because all we've got to do is the probability that it lands on 6, which is 0.39. So 0.39, and we'll just call that the expectation of the number of times it will land on 6 is 0.39 multiplied by the number of times we roll the dice, so multiplied by 200. So that gives us an answer. When we do that, type that in the calculator, we get 78. So we're expecting it to be 78 Answer 78. Okay, question 23. Complete the table of values for 2x plus 6 minus x squared. This is a quadratic, so we're expecting some symmetry in our table of values. Now, there are some tricks in the calculator you can use to be able to do this. You can set your calculator into the table mode, and your calculator will do all of this for you. However, you might not be confident in doing that. So what we're going to do is we're just going to look at a way of doing this without worrying too much. I'm going to start off with 0, which is the easiest one. So I usually start with 0. So we're going to go 2 lots of 0, which is, so we've got 2 lots of 0, which is 0 plus 6 minus 0. So that is just going to give us an answer of 6. Now, let's try typing 1 into there. So we've got 2 lots of 1. You can type this into your calculator just as it's written. So 2 lots of 1 plus 6 minus 1 squared. And using the brackets on the calculator is a really good thing to do here. So we've got 2 lots of 1, which is 2, plus 6, which is 8, minus 1, which is 7. So we've got 7. Right, let's do the 3 now. So let's do it. So we've got 2 lots of 3, plus 6, and then minus 3 squared. Type that into the calculator as it's written. You get 12 minus 9, which of course is 3. And that shouldn't really be a surprise because look at the symmetry. We've got a 3 here and a 3 here. And now what we're expecting to get is the same two numbers at the beginning for -2 and for 4. We're going to do the 4 because 4 is the easiest. So we've got 2 lots of 4 plus 6 minus the 4 squared. So let's have a look. 2 lots of 4 is 8 plus 6 is 14 minus the 4 squared, which is 16. So 14 minus 16 is -2. We've got -2 in there. And we're expecting the last one to be -2 as well. But let's just check. We've got in here, we've got 2 lots of -2 plus 6 subtract -2 squared. Now, I need to be a little bit careful here. This one, if you type it into the calculator, you'll get the right answer. But if you're not bothering with a calculator, be very, very careful with this. So you've got -4 plus 6. -4 plus 6 is 2. And we're going to take away, now -2 squared is -2 multiplied by -2, which is +4. So we're taking away +4. 2 take away 4, of course, is -2. So in there goes -2. Now we've got pairs of coordinates that we're going to plot. So I'm just going to write down the number of the coordinates that I'm going to plot. I'm going to plot the points -2, -2. I'm going to plot the point -1, 3. I'm going to plot the point 0, 6. I'm going to plot point 1, 7. Plot point 2, 6. 3, 3. And 4, -2. So those are my coordinate pairs. Just going to make sure that they're printed in there. So -2, -2 is down here. So -2, -2. That's the first point I want to draw on there. Next point that we're going to draw is -1, 3. So -1, 3. So -1, 3 is just here. Next point that we want to draw is 0, 6. We had 1, 7. 1, 7 is just here. Now it was symmetrical, so we've got 2, 6. We've got 3, 3. And we had 4, -2. So 4, -2 is down here. Now, when you draw this, and you draw these, and don't be tempted to draw this with a straight line. This should be a curve, and it should be a smooth curve. Smooth curves are often quite difficult to draw, especially when you're doing it with an electronic pen. But here we go. We're just going to draw a very rough kind of smooth curve here. I'm hoping that I can get this reasonably accurate as we go. So it's not too bad, this. So let's see here. So up to the vertex there. Okay, or the turning point, some people call that. And we're just going to bring it down the other side. There we are, we've hit that point. And then we're just going to take it down here and we're going to hit the next point, I hope. Okay. It's there. Okay, and we're going to look at the last part's going to be quite interesting because we're going to use our graph and try and use our graph to use the last to be able to solve the last part of this. So let's down here. And you can see the symmetry of this. It should be symmetrical about its vertex, which it is. And we've got there's my my graph. Now it says use your graph to find estimates of the solutions to the equation 2x plus 6 minus x squared. equals 0. So what's the same? What's different? Well, the left-hand side, 2x plus 6 minus x squared, is the same as the graph that we've just drawn. But instead of having y there, we've got an equals to 0. Where is it equal to 0? Well, it's equal to 0 at 2 points. It's equal to 0 just here and just here. So there are two values of x that we're going to that we're looking for here. So we're just going to zoom in a little bit and have a look and see what they are. And we can see that it says estimates. So we can see here that's -1, that's -1.5, that's about -1.6 there. So -1.6 is the first value of x. So we're just going to say in the graph we've got -1.6. So x is equal to -1.6. Or let's have a look at the second one. So x is equal to, just drag this over, x is equal to, let's have a look in here, 3.5, 3.6, 3.7. So it's about 3.7. X is equal to 3.7. Value in there. X equals 3.7. Yeah, x is equal to 3.7. Okay. Okay, so question 24 here. This really is literally just type it in as your calculator sees it, but or as you see it on your calculator. However, there are a couple of things on the calculator that are worth noting. When you type in the square root function on the calculator, so you find your square root button, you type that in, and you'll come up with a square root that looks like this. Then you hit the fraction key, which will give you something that looks like this, and it'll just be a little fraction. As you type, it will get longer and longer and longer. Now, all we're going to do in here is we're going to type in tan, and then it will come up with an open bracket. So you put 20 in there, and remember to close the brackets when you get to that. And we then say plus sine 25, and again, open brackets around it and close brackets. And then finally, tan 25 on the bottom, on the denominator there. Okay, so tan 25 minus sine 20. And all you've got to do at each one of those is remember to close the brackets. If you do that and your calculator is in the correct mode, it will give you the answer. Now, I'm just going to grab my calculator and do that on there. And I'm hoping that we get exactly the same answer as you do. So again, fraction key, tan 20, close the brackets, remember, plus sine 25, and remember, close the brackets, move the cursor to the bottom of the fraction, the denominator of the fraction, and then we're going to type in tan 25, close the brackets around that, minus sine 20, close the brackets, and then just press equals when you get to the end of that. And you get an answer of 2.515706913. So fairly straightforward approach on there. It's nothing, it's not too onerous, or I hope it's not. Now we should be able to get that, that working on there. So let's have a look. So 2.515706913. And then write your answer correct to 2 decimal places. Well, fairly obviously, we're going to just drop that off there. It's 2.51, but is it 2.51 or is it 2.52? So we look at the third decimal place, which is a 5. So look at that. That's a 5 just there. So we're looking at the 5 there. So we're going to cut that off, and it's going to be 2.52. So 2.52, because 5 or more. Okay, that's question 24. Question 25. Work out the value, or work out that 2.16 times 10 to the power of -5 divided by 2.5 times 10 to the power of -4. Now, if you type this into your calculator, exactly as it's written again, using the brackets, so make sure you remember to use the brackets, 2.16, and then we've got the times 10 to the power of button, so we just press that once, and then we put in a -5. Remember to use the negative button. It's on the left-hand side of the calculator above the numerical keypad. So that's going to be times 10 to the power of -5. Close the brackets, and then divided by 2.5 times by 10 to the power of -4. Remember, it's the times 10 to the power of button to be able to do that. And that gives us an answer. If you've done it correctly, you should get an answer appearing on your calculator that looks a bit like this. It should be 54 over 625. Now, clearly, that is not in standard form. So we're just going to press the SD button in there. That gives me 0.0864. Now, if we look at this and remember our place value columns, we've got the decimal point. We've obviously got the ones column, which is 10 to the power of 0. We've got the tens column, which is 10 to the power of 1. And if we're going on the right-hand side of the decimal point, we're going to go, that's tenths, which is 10 to the power of -1. The hundredths, which is 10 to the power of -2 column. The thousandths, which is the 10 to the power of -3 column. And by writing our number, we can keep going, and we've got the 10,000ths column, which is 10 to the power of -4. I don't think we're going to need any more than that, but if we type and write in our number, we've got 0.0864, so 864. Now, the leading digit of that is the 8, and so we write that as being the leading digit in our expression in standard form. So it's 8 point, and then 64 are the two digits that follow that, and it's times 10 to the power of. Now, at this point, we look which column the leading digit was in. The leading digit was in the 10 to the power of -2 column, so that gives it its place value, and that helps us to identify the place value. Okay, question 26. The density of orange cordial is 1.2 grams per centimetre cubed. The density of carbonated water is 1.01 grams per centimetre cubed. A drink with that should be a drink. Let's try and just change that. A drink. Let's try this again. So, question 26. The density of orange cordial is 1.21 grams per centimetre cubed. The density of carbonated water is 1.01 grams per centimetre cubed. A drink with a volume of 280 centimetres cubed is mixed by mixing 1 part of orange cordial with 7 parts of carbonated water. Work out the density of the drink. Well, okay, let's have a look and see what we've got with this. And we're trying to work out the density of the entire drink. So the volume of the drink is equal to 280. The volume of orange, well, we need to now think about how this is going to be, because it's 1 part of orange and 7 parts of carbonated water. So we're going to just have a little bar model here with 8 pieces in it. So let's draw this in here. So 1, 2, 3, 4, 5, 6, 7, and 1 more on there, takes it up to 8. So 8 pieces in there, and we've got water for 7 of them and 1 part orange. You know the whole thing is 280, so I want 280 there. So the first thing I'm going to do is do 280 divided by 8 to find out how much goes in each part. 280 divided by 8 gives me 35. So I've got 35 of orange, and then for the rest, for the water, we can probably just work out that that's 7 times 35, which gives me 245. So all of that is 245. My water. Okay, and obviously each one of those in those boxes is 35. Okay, well, we know that density is equal to mass divided by volume. So density is equal to mass divided by volume. And so we can, if you want to try and remember it with a triangle from your science, you can always go in here, my dad's van. Okay, so my dad's van. And we can say, okay, well, density is equal to mass divided by volume, if that helps you remember it. Now, okay, so we've got in here, density is equal to mass divided by volume. Let's have a look at the orange. So let's have a look at the orange then. So orange, so the orange density is 1.21. Is equal to mass divided by volume. So that's mass is 1.21. We know that the volume of orange is equal to 35. So that's over 35. And we know that with the orange, we'll call that sorry, not mass orange, so M orange. M orange there. So M orange divided by 35. Which means that the mass of the orange is equal to 1.21 multiplied by 35. Okay, so 1.21 multiplied by 35 gives me an answer of 42.35. Mass of orange is equal to 42.35 grams. Right, let's do the same for the water. Okay, that's 1.01 is equal to the mass of water divided by the volume of water. The volume of water was 245, which means that the mass of water is equal to 245 times 1.01, or 1.01 times by 245, which gives me a mass of water of 247.45. Now, the density of the entire drink is obviously the total mass divided by the total volume. So the density of my drink is equal to the total mass, which is 42.35, plus 247.45, divided by the total volume of the drink, which was 280. And we can probably just pop brackets around that just to make sure we're separating those. We can type that in to the calculator as it's written, and we get now 42.35 plus the 247.45, and divide that by 280. Gives me an answer of 1.035. So the density is 1.035 grams per centimetre cube. 27. ABC is a right-angled triangle. The point D lies on the line AC. AB is equal to 9 centimetres, so let's draw that in as 9. BD is equal to 13 centimetres there, so 13 going down there. And CD is equal to 4 centimetres there. Okay. Right, work out the perimeter of triangle ABC. Now, this looks like it's a Pythagoras' theorem question. So what we're going to do is we're just going to draw out triangle. You can see we know 2 bits of information about triangle ABD. So I'm just going to draw out triangle ABD as my starting point. So if I just do a little sketch of triangle ABD. Here we've got 9 and 13. Right angle down here. And I'm just going to say, I'm going to call this little length x. And I'm going to say, well, okay, if it's Pythagoras' theorem, x squared plus 9 squared equals 13 squared. So I'm going to say that x squared is equal to 13 squared minus 9 squared, just subtracting 9 squared from both sides. 13 squared is 169, and 9 squared is 81. So 169 minus 81 gives me 88. So x squared is equal to 88. So I'm just going to say that x is equal to root 88. I'm not going to put a decimal in there. I'm just going to leave that in its third form for now. So that is the length of AD. Now, we want to look at, now that we know that, we know everything that we need to know that there is about triangle ABC. So if we now do ABC, let's do ABC. So now we know that this down here, we know that we've got a length of 9, this length just here. We've got root 88 plus the length of 4, so plus 4. I'll pop that in some brackets because you might want to come back to that in a minute. And then we've got this length here, which I'm going to call y, which we also don't know. Now we need to know what that is. So let's just type that into the calculator again. So what I'm going to say now is that 9 squared plus root 88 plus 4 all squared is equal to y squared. Now, if I do that, so we've got root 88 plus 4. So root 88. Remember to take the cursor outside of the square root there if you're going to do that, plus 4, and square it. Okay, so square that. Okay, and then we get plus 9 squared, which is 81, and then square root of that. And my calculator gives me a fairly unpleasant answer there. So it gives me, so for y squared, it gives me 260.005 roughly, and that's equal to y squared, which means that y is equal to the square root of that. So square root of my answer there is 16.1. And we want it to 3 significant figures. I'm just going to keep 16. I'm going to go 16.12 just to be sure. Now all I've got to do to work out the perimeter, I just need to add my 3 sides. So the perimeter is equal to, over here, so the perimeter is equal to 9 plus root 88 plus 4 plus the 16.12. So adding all those together, and we get an answer for our perimeter of 38.5. My perimeter is equal to 38.5 centimetres. And 4 marks for that. Another m is rounded to 1 decimal place. The answer result is 9.4. Okay, well, let's have a look and see where 9.4 lies on our number line. So it's been rounded to that. So 9.4 sits in the middle. And either side of that, we've got 9.5 and 9.3 are the other two that have been rounded to 1 decimal place. Now, what we're looking for here, of course, is what numbers would have rounded to 9.4. So they lie between this point and this point, and they lie between 9.35 and 9.45. And that is called our error interval. So it's just 9.35 to 9.45. 9.45, of course, is the first one that rounds up, which is why you've got the inequality that says less than rather than less than or equal to. Another right angle triangle, calculate the length of AB. Nice, fairly simple thing. Here we've got the opposite side. Here we've got the hypotenuse. I want to bother labeling the other side. And if we know that it's opposite and hypotenuse, we know that's going to be sine, or sine ratio. So if you need a reminder, SOHCAHTOA. Of course, that's on the formula sheet as well. So you can always kind of go back and revert to using the formula sheet. Now, so we want this bit here, and we want our opposite, so AB. So AB is the opposite, that's just at the top there, is equal to sine 38 multiplied by 16. Okay, and we end up with AB is equal to, when we type that into the calculator, 9.85 to 2 decimal places. 9.85, and it's centimetres, so 9.85 centimetres. And we'll stop there for a moment. Question 30. On this question, we're just going to work out what we can. And the only thing that seems obvious to me that we should be doing here is expanding the brackets. So we get 6 lots of x, so 3 times 2x is 6x, plus 3 is equal to 4 lots of 5, which is 20, minus 4x. Now, with these questions where you've got x on both sides, it's usually an idea to start where we've got the lowest number of x's, which is the right-hand side. So because negative 4x is less than 6x. So I'm going to make a 0 pair with that by adding 4x to both sides. So add 4x there and add 4x here. And we get 10x plus 3 is equal to 20. Now, it's a fairly simple solution here. We're just going to subtract 3 from both sides, make a 0 pair with the plus 3. So we get 10x is equal to 17. And then x is going to be just dividing by 10 on both sides. Divide by 10, divide by 10. And we end up with x is equal to 17 over 10, or 1.7. So x is 1.7. And question 31, last question on this paper. Question 31. Each interior angle of polygon is 150 degrees. So if we have a polygon, here's a polygon like this, and how many sides it's got, just draw a bit of a polygon. We know that that's 150 degrees, so 150. That means that the exterior angle must be, the sum to 180 will make that 30 degrees. Okay, and we should know that the sum of the exterior angles of any regular polygon is, or of any polygon in fact, is 360 degrees. So the last thing we're going to do is we're going to do 360 divided by 30, which of course gives us an answer of 12. So 12 sides. And there we are. We have finished the paper.